So here we have another function to graph, and it turns out that this function is even. If you put in a negative x, it's not going to change the numerator and it's not going to change the denominator. So there is symmetry here. It's an even function, so it's symmetric about the y-axis. So that's great. That makes it a little bit easier when we go to find points. Okay, let's find the y-intercept. So what is f of 0? So you're plugging in 3 times 0 squared over 0 squared minus 4, which is going to be 0 over negative 4, which is just 0. Okay, so that means it goes through the point 0, 0. Okay, so remember that. We'll remember that. And now let's find x-intercepts. Well, x-intercepts are going to be when the numerator equals 0. So when does 3x squared equal 0? Well, when x equals 0, which gives you the same point 0, 0, right? Okay. Now let's find asymptotes. So vertical asymptotes. Vert asymptotes. When does x squared minus 4 equal 0? You could factor that, or you could put 4 on the other side and take the square root of both of them. I'll just factor it real quick. X plus 2 and x minus 2. So you're going to have one at x equals negative 2 and one at x equals 2. So there will be two vertical asymptotes. All right? So we're getting all our information together and then we'll graph it. What about horizontal asymptotes? Well, in this case, we've got n equaling m, same degree in the numerator as the denominator. And so it's going to be y equals 3 over 1, or y equals 3. That's going to be the horizontal asymptote. Okay, and then we just need more points. So to get more points, we're going to have to look at what we have. Now, the book describes it a little bit better, and I'll try to do that here. So we know it's symmetric about the y-axis. We know it goes through the point, the origin. So there it is. And we've got a vertical asymptote at negative 2. And we've got a vertical asymptote at 2. And then we've got a horizontal asymptote at 3. 1, 2, 3. So you can see the asymptotes kind of divide this into different sections. So we want to find points about the vertical asymptotes and the x-intercepts. That'll tell you which direction things are going. So we can look at that. So let's find f of 1. So let's just plug in 1. 3 times 1 squared over 1 squared minus 4. That's going to give me a 3 in the numerator, a negative 3 in the denominator, and I'm getting a negative 1. That is an ordered pair, 1, negative 1. 1, negative 1. Okay, so I kind of did that fast, but hopefully you paused the video or something. Anyway, that is a point. Now, what did we say about the symmetry? We said it's an even function. Therefore, there's another point on the other side of the y-axis. That's great. Now we know what's happening in that middle section between the two asymptotes. It's going down this way, and it's going down this way. So we know that's happening, so that's good to know. We kind of need to know what's happening over to the right, though, and so we need to find something like f of 3. So I'm looking like when x is 3 right here. I can't put in 2 because that's an asymptote, but I can go to 3. So I have 3 times 3 squared over 3 squared minus 4, which is going to be, see, 9 times 3 is 27 over 9 minus 4 is 5. Okay, so what's that? What's 27 divided by 5? It's like 5.4. I'd like to know, so I'm going to grab my calculator. It's late at night and I can't see. 27 divided by 5. Yeah, 5.4. Okay, so I have another ordered pair. That ordered pair is 3, 5.4. I didn't write, when we had 1, negative 1, there was another ordered pair, negative 1, negative 1. I graphed it, But that's because of that symmetry. So if I have the point 3, 5.4, there's another one at negative 3, 5.4. Okay, and we can graph those. So 1, 2, 3, and then 1, 2, 3, 4, 5.4. So maybe about there. And then let's look at the other side, which is going to be about there. Okay, maybe I want to find one more point. Let's find f of 4 just to do some extra work here. Okay, so 3 times 4 squared. I mean, we're pretty sure we know what's going on probably, but let's just check it out. Okay, so I have 16 times 3, which is 48 in the numerator. And then 16 minus 4, 16 minus 4 is 12. Oh, I think that's going to come out even to be 4. So that gives me the point 4, 4. Interesting. That means there's also a point negative 4, 4 on the other side. Okay, so 4, 1, 2, 3, 4. There's a point, and then there's also one over here at negative 4, 4. Okay, that gives me a really good idea what's going on. Now I know it's going like this. And I know it's going like this. And so we get that for our graph. So there we go. These are very rough sketches. We don't expect them to be perfect. If we wanted a perfect graph, we would use a graphing utility. And these just give us a rough idea. We're taking all these pieces about things that we know about rational functions. We're putting them together to get a rough sketch. Okay?